All right. Hello, everyone. My name is Abby, and I'll be going over how do schematics work and also going over an application called Eagle CAD to create these schematics. So what is a circuit schematic diagram? A circuit schematic diagram is basically an illustration of electronic components being wired and showing where they're assembled on a circuit board or PCB board, which stands for printed circuit board. So as you can see here, this is just a basic schematic that you'll be creating later on. This is created in the application I talked about earlier, Eagle CAD. And this is basically just a skeleton of what this is to what you can see over here, just a basic board of a circuit. So this is just a skeleton of it basically, and this is what you'll be creating. So what are the main components of a circuit? So all circuits need to have three basic elements: a voltage source, a conductive path, and a load. A voltage source could be a battery, is needed in order to create a current to flow through a circuit. A conductive path is needed to be able to provide a route for the electrical current to flow. And there needs to be a load, an element that consumes that power from the battery, such as a light bulb. So what are the electrical units that are used? The main units that you'll usually see in an electrical circuit are volts, amps, and ohms. Other units you usually see in there, but it depends on the type of project that you're working on that you'll see these type of units. But the main units that you'll see are volts, amps, and ohms. So, skipping ahead a little bit. So volts are basically the electrical unit of voltage. Voltage is what makes electric charges move. Amps are the unit for measuring current, current being the rate at which electrons flow past a certain point in a completed circuit, current being the flow, and ohms being the unit of resistance. Resistance is basically the measurement of the opposition to current flow in an electrical circuit. So how do we identify electronic components? The ones that you see here are just basic ones that you'll see frequently. There'll be more info on the slideshow of the links that you can click on. But some of the basic ones that you'll usually see or frequent ones that you'll see are just capacitors. Capacitors are devices that store electrical energy. Resistors, they reduce current in an electrical circuit. There are two different types of resistors you'll usually see. The top one here is used internationally, but the bottom one here is usually used in North America. A battery, an electrical power source, an LED, a light emitting diode, a semiconducting light source that emits light when current flows through it, a diode, a one-way switch for current to flow. It allows current to flow more easily in one direction. An IC, an integrated circuit, an electronic component that has a micro electrical component components that are made to perform a specific task. The IC that you'll be using in the project that you'll be using to create on Eagle CAD is a timer. That's basically the IC that you'll be using. That timer is performing a specific task for the project called a blinky board to set the LEDs off at a specific rate and time. So how do we identify DC voltage source? So what is a DC voltage source? A DC voltage is direct current, meaning there is a polarized source of electrical energy, a positive and a negative. So positive voltage sources you'll see are POS, VCC or plus sign, negative ground, GND, RNT, return, or just a negative sign. As you can see in the schematic here, a VCC being the positive and the ground being the negative source. So electrical circuits. I was talking about that earlier, that each circuit needs three main components: a voltage source, a path for the voltage source, and an element that is needed for that voltage source. So an open and closed circuits are pretty self-explanatory. An open circuit is just basically when two external points of the circuit are just not physically connected together. So current is not flowing through it. A closed circuit is a completed electrical electrical current circuit where all the connections are together and everything is flowing through it. As you can see here, this would be a completed circuit, or yeah, this would be a closed circuit, and this would be an open circuit when two external connections are not connecting together. A series circuit is a path along of which the whole current is flowing through each component. So the battery, what this is flowing through each part of the circuit. So it's flowing through the resistor 1, resistor 2, resistor 3. There's nothing branching off out of this part of the circuit, or yeah, nothing is being, the current is not being divided anywhere. There's just one whole loop of the current flowing through each electrical component, compared to a parallel circuit, which there are branches in the circuit that create current to divide through it. So the battery source current is being divided through each path of the circuit. So the voltage will be different than what it would be here, that the voltage would be the same everywhere, but the current will be the same everywhere, but the current in these branches will be different since it's being divided throughout these 3 branches. A short circuit is basically when a positive and a negative voltage source in a circuit are joined together. So this is what we do not want in a circuit. It'll create a spark or a blow in a circuit. It can be very dangerous sometimes, or most of the time actually. So now actually trying out Eagle CAD. Eagle CAD, like I said earlier, is just basically a software that allows you to create a PCB board that connects with schematic diagrams. So on the slideshow, you'll just be following tutorial 1 of how to assemble and familiarize yourself with electrical components. This link is to actually download Eagle CAD. If you're using a school computer, you need to get an administration password to actually download it on your computer. If you have a personal computer, then you can actually get it downloaded for free on there. So yeah,